Camera. 1 minute.
In this session, we will present 3 invited lectures, and 1 lecture is online, while the 2 are presented physically. So, our first speaker in this regard is our Honorable Professor Dr. Savannah Shadi. She is working as a professor there at ICCBS, as a senior body, and her research title interest in food design and synthesis of peptidomimetic and cyclic peptide libraries by parallel in split food specialties and phytochemical studies on the medicinal plants. She has many publications, patents, and awards to her credit, including OWSP Award for Young Women Scientists from developed world. So, her title of presentation is Discovery and Preclinical Studies of New Drug Candidates for Treatment of Epilepsy and Stroke. So, I would invite her to please come forward and present her kind lecture. Thank you.
Thank you very much, Doctor. Now, I will present some of our studies on preclinical development of new drug candidates for the treatment of epilepsy and stroke. My presentation has 3 parts. The first part is on discovery of potent anticonvulsant nitrophorate isoxazoline, which were discovered as active principle of folk medicine plant and as it is already been presented by Professor Gaurav and Professor Dr. Iqbal. So I will just present here some more details of this work. These compounds are identified as potent sodium channel blocker and as neuromodulating agents, and we have 2 US patents on this discovery. Second part of my presentation is on the development of Z-acid as the most potent analog of isoxazolines in stable and single isomeric Z configuration. Thermal stability, toxicity, and biomarker analysis of Z-acid was also completed. And then we also developed the nasal formulation of Z-acid, which showed 100% control on PTG-induced epileptic form activity in rats and in intranasal experiments. Nasal formulation also protected rats from 2-vessel occlusion ischemic injury in vivo stroke model. Then a third part of my presentation is on preclinical research on Z-acid nasal formulation, acute and chronic toxicity. In mice, rats, rabbits, primate studies proved the safety of Z-acid nasal formulation, and genotoxicity, hemolysis, cellular level toxicity data also proved its safety. Then we also compared the pharmacokinetics of Z-acid through intraperitoneal and nasal route of administration. We have filed patents in Pakistan, USA, China, and European Patent Office, and ethical approval for phase 1 clinical trials is now applied. These are our patents in different countries. Epilepsy is a chronic neurological disease that affects people of all ages. Around 50 to 60 million people have epilepsy, and 80% of the epileptic patients reside in developing countries. About 90% of epileptic patients in developing countries are not receiving appropriate treatment, and this disease is more common in young children and older people. There are many anti-epileptic drugs, but they are linked to adverse side effects, lack of efficacy, and lower IQ that also reduces the quality of life. Sudden unexpected death in epilepsy is the most common cause of death in chronic uncontrolled epileptic patients. Currently, about 30 approved FDA-approved anti-epileptic drugs are available for the treatment of epilepsy, and several of these anti-epileptic drugs are also approved therapies in non-epileptic conditions, including neuropathic pain, migraine, and generalized anxiety disorders. Complete elimination of seizures is not achieved with the current anti-epileptic drugs in about 1/3 of patients. And these anti-epileptic drugs work by different mechanism of action. They act by modulation of voltage-gated ion channels, by acting on GABA or glutamate receptors, or by combination of these mechanisms. So due to differences in their mechanism of action, most of the anti-epileptic drugs do not control all type of seizures. Cost to develop one new drug from R&D to marketing approval is in the range of $944 million to $2.8 billion, and that requires an average period of 9 years. So overall success rate of CNS drugs during clinical development is also very low, and due to high cost involved, there is no innovation in the anti-epileptic drugs available. The new drugs are second and third generation and analogs of conventional anti-epileptic drugs, and they are more expensive than older drugs in Pakistan. The natural product based drug recently approved Epidiolex, that is approved by FDA for the treatment of resistant epilepsy, is available at very high cost. The cost for one patient is about $32,000 per year. It's not available in Pakistan. Most people with epilepsy take anti-seizure medicine on a regular basis to prevent seizures. Some patients experience increased seizure activity, that is called seizure clusters or acute repetitive seizures, which require rescue medicine that can be immediately and easily administered to suppress the seizures. Intranasal administration offers a great potential for direct nose-to-brain drug delivery to control seizures in emergency, and benzodiazepine class of compounds are mostly rescue medicine. They are administered via buccal, rectal, and nasal route, and they get into the bloodstream rapidly to suppress the seizures. Intranasal application of benzodiazepine are considered preferable over rectal and intravenous application. FDA has approved these 2 nasal spray and 1 rectal gel based on this old class of anti-epileptic drugs. And the cost for nasal spray, which are now, the first one is approved by FDA in 2019 for treating seizure clusters, is the cost is for 2 supplies more than $500, and diazepam based nasal spray is also around having the same cost for a supply of 2 spray. These rescue medicines are effective in short-term treatment of all seizures. They are used in emergency situation only, and tolerance develops in most of the cases within a few weeks. And their effectiveness also reduces over weeks and over a period of time, while their side effects increases since the dosage has to be increased to maintain the same level of effectiveness. So in our studies, we use 3 in vivo models that are validated, and they are used to identify new anti-epileptic drugs, maximal electroshock seizure test, subcutaneous pentylene tetrazole test, and the third one is kindling model of epilepsy. The maximal electroshock test, also called electrical induced in vivo epilepsy model, is the most common use seen in the search of new anti-epileptic drugs. And generalized tonic-clonic seizures with hind limb extension followed by clonic seizures are induced by application of electrical stimulus in mice or rats. Drugs that are effective in maximal electroshock test, they also inhibit the sustained repetitive firing of neurons through an action at the voltage sensitive sodium channels such as phenytoin. And the behavioral and electrographic seizures produced in this model are consistent with the human disorders. The other second test is chemical induced in vivo epilepsy model, and in this subcutaneously pentylene tetrazole or pilocarpine, bicuculline or strychnine, these chemicals which are conversant, they are used to induce seizures in experimental animals. And drugs which are effective in they have different mechanisms. Effective in PTZ model is As mentioned by Professor Torreman and Professor Iqbal Chaudhary, several plants were identified through ethnobotanic survey. And among these plants, we selected Delphinium danudatum based on its weak activity of the food ethanolic extract of this plant. This plant is traditionally used for the treatment of epilepsy, migraine, paralysis, pain, and as antidote for snake bite and scorpion sting. In Unani system of medicine, Jadwar, which is the common name for Delphinium danudatum, is considered as antipyretic, antiseptic, anti-inflammatory, anticonvulsant, antidote, cardiotonic, and tonic for the brain. So we use biosolic isolation strategy. 7 kg of Delphinium danudatum plant were used in the first experiment, and ethanolic extract was prepared, which was then partitioned between hexane and chloroform extract. Since delphinium plants are reported to have diatopenide and non-diatopenide alkaloids, which are very toxic, so through this strategy, we were able to separate the toxic constituents or toxic alkaloidal constituent in the chloroform extract at different pH, and we further identified the structure of these toxic constituents which are present in the chloroform extract. So the aqueous extract, which was obtained after the removal of chloroform extract, was found to be the least toxic extract, and the anticonvulsant constituents were predominantly present in the least toxic aqueous extract. Then we studied the effect of aqueous extract in vivo model and in vitro models. In vitro studies, aqueous extract strongly inhibited the sustained repetitive firing of hippocampal neurons at the dose of 0.6 milligram per kg, and this action was also dose dependent. This mechanism was similar to standard anti-epileptic drugs phenytoin, which also showed the suppression of sustained repetitive firing of neurons in dose-dependent manner. Then we also studied the effect of aqueous extract on PTZ-induced epileptiform activity, and we found that at the dose of 0.6 milligram per ml, seizures were completely inhibited. And the same result was obtained when we checked the effect of aqueous extract on bicocline-induced epileptiform activity. So further fractionation of aqueous extract resulted in the isolation of an oily material that was 10 times more active than the aqueous extract. And this oily material from aqueous extract also inhibited the sustained repetitive firing of neurons at the dose of 0.06 milligram per ml. This oily material from aqueous extract also showed a strong anticonvulsant activity in mesh test, and it protected 100% animals from highly tonic extension phase of this model. This oily material also suppressed the PTZ-induced seizures by 100%, similar to anti-epileptic drug valproic acid. Bicocline-induced seizures were also inhibited by this oily material that actually indicate that this part of the plant or this oily material actually contains molecules which are capable of having interaction with GABA or receptors also, and also they are able to express the sustained repetitive firing of neurons through some kind as shown by other anti-epileptic drugs. So this oily material also inhibited the PTZ-induced epileptiform activity of hippocampal neurons in culture cells, and bicocline-induced epileptiform activity was also material led us to isolate isomeric mixture of isoxylitol. This is the summary. We further confirm that through synthesis that the natural product has anticonvulsant activity, and During my UNESCO Laureate Fellowship in Southampton University, I worked with Dr. Ganson on Dr. Iqbal actually sent me for postdoctoral training in combinatorial chemistry. There I got the opportunity to synthesize this compound under the guidance of Professor Dr. Ganson, and then we confirmed that the structure and biological activity of natural product. Then again, we slightly modified this strategy, which we first did. In the second strategy, we used this acid analog also to synthesize isoxylaton, and then we developed a procedure through which we can obtain Z acid analog of isoxylaton in bulk amount, and then we further developed the nasal formulation of Z acid to check its effect in central nervous system disorder. So the anti-epileptic compound Z acid was discovered as potent and analog of isoxylaton, and you can see here that these represent a new class of anti-epileptic natural products. These are the structures of the available drugs, and these are small molecules, and then we further develop them as nasal formulations. Then we completed the preclinical development of Z acid. Z acid obtained from different production lots showed reproducibility of activity in acute and killing model of epilepsy. It was found configurationally stable at different temperature, and we determined its purity through NMR, GCMS, and VPLC profile. And in acute acute PTZ test, we found that Z acid at the dose of 300 milligrams per kg prevented the seizure effectively. Then we checked the effect of the Z acid in kindling model of epilepsy to evaluate its anti-epileptogenetic activity. Total duration of study was 35 days, which include 18 doses of PTZ, and the experiment was ended when once the animals in the kinder group they showed a stage of 4 or 5 seizures according to the scale established. So when this PTZ in subconvulsive dose that was determined to be 50 milligram in our whereas 4 started after 14 doses. We checked different doses of Z acid, and we found that Z acid at the dose of 300 milligram per kg for 1 to 2 started from 14 dose followed by then preclinical research was performed, and we evaluated the toxicity of Z acid in mice in acute test, which was the toxicity of different doses of Z acid was checked, and animals were monitored for 24 to 48 hours, and we did not find any neurotoxic effect of Z acid during this period. Then we further extended this study for 3 months, and in subchronic toxicity studies for 3 months with the daily dosing of 300 milligrams per kg. We did not find any toxic effect. All animals survived until the end of experiments, and blood samples were processed for LFT profile and all biochemical parameters. Gross anatomy of organs after the treatment, there was no sign of toxicity, and all biochemical parameters were found in the normal range. Then we developed Z acid nasal formulation. Since there is a pressing need for new CNS medicine that can be delivered directly to the brain in therapeutic quantities whenever a seizure or any such condition arises. So nose to brain delivery represents a big challenge, and development of nasal formulation which is able to deliver drug directly to the brain, is very important. Direct to nose to brain delivery or through nasal formulation overcomes all problems which are connected to the oral drug administration, and that also avoids the difficulties due to blood-brain barrier and all other problems associated with the systemic administration, and such as bioavailability and other side effects. So we checked the effect of that acid nasal formulation in PTG-induced seizures and recorded through EEG. Z-acid nasal formulation was administered 30 minutes before PTG injection, and we did not see seizure-like activity in this case. So in animals treated with Z-acid, 100% control of formulation was observed, and it was found 6 times more effective than IP administration. Then we also studied the BDNF and CFOS expression, which these BDNF and CFOS, they are overexpressed during seizure activity. So Z-acid or nasal formulation also expressed both of these markers. And the animals were having the glutamate level were also checked, and we found that Z-acid also showed prominent potential to reduce the glutamate levels in the cortex and hippocampal region of the brain, and that were shown here. Then we also checked the effect of nasal formulation in stroke, in vivo stroke model. Stroke is represented as an acute attack of partial dysfunction of brain, spinal cord, or retina. Stroke is classified as ischemic or hemorrhagic, and where 85% cases represent ischemic stroke. Stroke is a debilitating illness, rendering thousands disabled and leading a significant proportion of people to death worldwide. In an industrialized country, stroke is considered as second leading cause of death and major cause of acquired adult disability. There is no effective treatment for this, and thrombolysis is the currently available option, which has certain limitations. In our experiment, we found that Z-acid is non-toxic to primary cell culture of red cortical cells. It rather differentiated the cortical cells. You can see here, or after 48 hours, the cells were differentiated into neuronal cells. So we, my collaborator, Dr. Shivana and her group, they established this model, two-vessel occlusion model of ischemic stroke. After the induction of this model, Z-acid nasal formulation was administered through nasal route for 7 days, and after this, these experiments were samples were processed further. Z-acid significantly protected rats, as you can see from here. No signs of infarction were observed in treated and sham control and control animals, and that indicated its usefulness for the prevention and treatment of ischemic injury. And we further immunochemistry was also performed after 7 days post-stroke, and we found that Notch1 and neurogenin-2 expression was significant in the cases in cortex and hippocampal region of brain. There were prominent expression of these markers which help in proliferation and differentiation of neurons. Then we also studied the anti-anxiety effects of Z-acid in rat model of anxiety. And since benzodiazepine class of compounds are mostly used as so we also studied the effect of Z-acid nasal formulation through behavioral test. And this Z-acid is anxiety was induced by subjecting animals to acute stress, and there were 5 groups of animals, and Z-acid and diazepam, we used this standard drug diazepam to compare our results, and they were administered intranasally 3 days before the exposure of stress. After this, we then checked the behavior in open field test and social interaction test. In open field test, model rats showed significantly elevated freezing time and decreased pair crossing and grooming time as compared to control, and these results indicated a significant reduction of anxiety-like behavior in rats when expressed to stress only. So in cases where the Z-acid and diazepam were treated, these treatments helped to normalize most of the anxiety-like behaviors in open field tests. And same observation was found in the other test also, which is social interaction test. So that actually showed that the Z-acid has strong potential as anti-anxiety medicine through nasal route of administration at the dose of 12.5 milligram per kg. Then we studied the toxicity of Z-acid nasal formulation in mice, rats, and rabbits by using nasal route of administration. And in rats, we first conducted the study for 3 months, then for 6 months, and then we checked all biochemical parameters were found in normal range. And in rats, after treatment for 6 months, test animals showed no normal pigmented nostrils like normal animals, and no signs of redness were observed after 6 months. And then in rabbits, first we determined its toxicity for 24 hours in acute test, and then further extended the study for 1 month, and we found all biochemical parameters were in normal range. We also determined the safety of Z-acid nasal formulation used in pregnancy, since antiepileptic drugs are reported to have cytotoxicity or genotoxicity in embryonic fetal cells and have DNA damaging effects. Antiepileptic drug used in pregnancy is associated with increased risk of spontaneous abortion and cause serious harm and teratogenic effects on the fetus. While in our experiments, it was found that antiepileptic drugs Z-acid showed no teratogenic effect on newborn pups, and it showed no toxic effect on female reproductive system. We also studied the genotoxicity of Z-acid. Micronuclear test was used. 3 groups are used, and we used control with as untreated group and cyclophosphamide in cytotoxic drug, and Z-acid was injected through an intraperitoneal administration. So after 24 hours, cells were stained, and we found that in untreated control, normal morphology was found in all types of cells with no sign of damage. In the cytotoxic drug treated group, we found many micronuclei in polychromic and normochronic erythrocytes, and at the dose of 40 milligram, while Z-acid treated at dose of 300 milligram per kg, we found no micronuclei in the cells. So cytometry data also supported this result, and hemolysis activity of Z-acid was also checked at different concentrations, and it did not show any toxicity. So Z-acid was identified as non-mutagenic and non-teratogenic agent, and genotoxicity in vitro and vivo toxicology studies of Z-acid nasal formulation in mice, rats, rabbit, and primate models proved its safety in animals. Then we also checked the pharmacokinetics of Z-acid in primate model. 3 different doses were used. Their peak concentration was achieved in between 20 to 40 minutes of drug administration. And the plasma half-life through nasal route of administration was found 30 to 40 minutes. And then we also compared the pharmacokinetics of Z-acid after IP and nasal administration in rabbits. Through IP administration, Z-acid rapidly appeared in plasma. Peak concentration was achieved within 15 minutes, and it remained there for more than 3 hours. While in intranasal experiment, it appeared, the peak concentration was achieved within 15 minutes, and it disappeared in 2 hours. We also compared this. This is my last slide. I'm going to complete now. Thank you. So in rats, we compared the pharmacokinetics of Z-acid after IP and nasal administration, and in the plasma, in IP administration, in peak concentration was achieved in plasma within 5 minutes, and it disappeared in 2 to 2.5 hours. And in brain samples, it appeared, the peak concentration was appeared within 15 minutes, and it disappeared within 1 hour. While in intranasal experiment, in the plasma, peak concentration was achieved within 50 minutes, and it disappeared from the plasma in more than 3 hours. But in intranasal experiment, the compound appeared within 5 minutes in brain, and then it disappeared from the brain within 2 hours. That is showing its effectiveness, that is going immediately in the brain samples. So through these studies, we discovered new class of anti-epileptic drug candidates. We established the non-cytotoxic nature of isoxazoline, and also studied its in vitro and in vivo mechanism of action. Then we developed Z-acid and its nasal formulation. We also had this molecule, this analog, which is also showing effectiveness in nasal administration. So these new class of anti-epileptic drug candidates were discovered, and they showed potent anti-epileptogenic activity in acute and kindling mode of epilepsy. And we completed the biomarker analysis, preclinical studies in rats, rabbits, primates, and they were also identified as neuromodulating agent. They can be used to treat this CNS disorder, including stroke, epilepsy, and anxiety with more efficacy and safety than existing drugs. Thank you very much. I would like to acknowledge Professor Dr. Sauriman and Professor Dr. Mohammad Iqbal Chaudhry. And they actually initiated this project, and I became the part of their research project when I joined them as PhD student. I completed my PhD under the direct supervision of Professor Dr. Iqbal Chaudhry, and then I did synthesis, first synthesis in Dr. Genson lab in University of Southampton. I would like to acknowledge Dr. Shabana Singhji and Dr. Zahra Batul. Dr. Shabana Singhji and her research group has extensively worked on the pharmacology and on mechanism of action and toxicity. Dr. Rukesh, he actually worked he actually performed all toxicological and pharmacokinetic studies was done by Dr. Rukesh, and Dr. Nadeem Mulak was involved in the bulk scale production of ZSA. So these are my students who assisted us in the lead optimization and synthesis of anti-epileptic molecules, and the PhD students of Dr. Shabana Singhji also working. Ms. Maha Shahid has worked on in vivo spoke model. And I would like to acknowledge the funding from Higher Education Commission and our field project and Technology Development Funds from ACC for the development of first drug candidates from Pakistan for the treatment of epilepsy and other central nervous system disorders. Thank you very much.
Thank you very much for a very nice presentation. As we are coming short of time, so therefore I think that there is no need to have a question. So we would just proceed for another session, but before that, I have to present a gift from the organizing committee. So, our next speaker is Mustafa Canadian from Isfahan, Iran, Department of Pharmacology, Isfahan University of Medical Sciences. Dr. Mustafa Canadian has won several awards. For example, this presentation award is 13th Iranian Pharmaceutical Sciences Congress 2012, Best Innovation Award in 17th Monthly Congress on Medical Education in Isfahan University of Medical Sciences. He published several papers, more than 145 articles in the field of population and spectral investigation of useful natural products, synthesis of natural products, pharmacology and bioassay evaluation on natural products. He has won several fellowships and also got several training, isolation of ligands from different species and their structure investigations at National Center of Natural Product Research, University of Mississippi of Fort, USA, and also other several awards, numerous awards. For the sake of having time, I would call Professor Dr. Mustafa Canadian to present his title of research, new sequiterpene lactones from Artemisia species and their cytotoxic and anti-lethal activities. So please come forward to present to us.
Thank you very much, ladies and gentlemen. We're going to speak about sequiterpene lactones. Because of that, we should first start from Astracea, family, and one of its famous plants, Artemisia. This dog is derived by student Mariam Pakaria, his PhD, and also my other friends, and especially Dr. Mustafa Ali my friend, which we are in contact together for checking the structure, the history, absolute configuration, that everything will be fine in Mississippi University and an FDA in United States. I am from Islam University of Iran in a religious city, Islam, full of beautiful mosques. They are Muslim people like to go to Islam and see these mosques, beautiful bridge on a line river, and also old palaces and very famous handicraft carpets and full of handicraft stuffs. At least more than 100 handicraft stuff are produced in this one. The occurrence and distribution of sesquiterpene lactose are interlocked with plant kingdom Asteraceae family. Asteraceae is a major reservoir of sesquiterpene lactase with a big structural diversity. Artemisia is one of the largest genera in the family Asteraceae, is widespread genera with over 500 species. In ethnobotany, Artemisia is used for treatment of fever or antihelmintic or like that, or for gastrointestinal tract disorders. And recently, it is more focused for anti-cancer activity and anti-protozoal activity like anti-malaria and anti-leishmania. We are speaking about two species, Artemisia khorasanica and Artemisia pupittarensis, from a very rich but poor study in Auditorium region. In between Pupittah Mountains in Salt National Park. So we can start the work and speak about extraction. Some very usual extraction at all, together, isolation and elucidation and something like that. We extract using dichloromethane and acetone to avoid very polar compounds. 2,4 dichloromethane and 1,4 acetone. After that, we get very oily and full of chlorophyll extract, 600 grams. To get rid of this fats and chlorophyll, we use paraffin-coated silicogen. We can use reverse ODS silicogen. It is also available, but because reverse C18 silicogen is fat, is less than 12%. Usually it is 6%, 7% is fat or around that. We need at least 50% carbon on silicogen. Because of that, we coat the paraffin with silicogen and wash the extract through a sinter column. This sinter column, retains very nice chlorophyll and fats by washing methanol water with 70% methanol, 30% water. After that, we get 14 fractions. But after getting the NMR and TXC profile, we selected only 4 fractions for getting sesquiterpene lactose. As you know, Artemisia species are very rich in flavonoids. So you should to get of these flavonoids to take very small quantity of sesquiterpene lactose. In 600 grams of extract, we got only around 10 milligrams of sesquiterpene lactose, not more. How we isolate the compound? After selecting the fraction, we submit it with another column chromatography using fluorochromatography methanol 9:1. After that, we submitted the fraction, the selected fraction of Stepadex to remove phenolic compounds. Stepadex is very selective for separation of tannins and also remain phenolic compounds like flavonoids. After that, this subfraction is ready for injection to recycle HPS. When I was here, I learned how to use recycled HPS. When I returned back to my country, I prepared a recycled HPS by my own, by my method. Using a water system and a recycle bar. In this system, we are using a UV detector and refractive index detector. And we modified this system to a recycled HPLC system. By recycling HPLC system, only by using a little amount of HPLC, expensive HPLC solvent, but for example, 600 milliliter, we can run HPLC. But without this system, we should to use gradient HPLC system with every time for some preparative column or preparative column, it needs more than liters, at least 30 liters of expensive HPLC solvent. However, we get 16 compounds, 16 sesquiterpene compounds from this extract. Then we go further for detection and elucidation to different usual sophisticated spectral system. We got trillium compounds in addition to trillium non-compounds from this plant. And also, we got 4 new compounds from Artemisia foracinica in addition to 1 non-compound. And in addition, we go for synthesizing of some other new compounds from one of the compounds should get in good quantity. We elucidated the compounds through usual NMR system, HNMR, CNMR, there, and else. Hydrogenation mass, and we go further for relative extraction configuration. Even so, the sesquiterpene lactones are small molecules, but because of their stoichiometry and their position, sometimes and overlap peaks, sometimes detection of the peaks in noisy spectra is very difficult. In this case, we have another problem also. We have different only in orientation of one hydroxy and methyl on C14 in this part. So we go further for taking absolute structure configuration through electronic circular through ECD spectra, we take ECD from the compounds, most compounds, and also we go to the Gaussian program and prepare different conformers of compounds, and after minimizing the compounds, we get this in the spectrum, and not this ACD spectrum, as you saw, as you see. In compound 1, we have one negative peak around 211 and one positive peak around 224. It is in calculated ECD, which is treated well with experimental ECD and confirmed the structure. As draw here, it's a draw here. But in the case of compound 2, as you see, in compound 1, alpha protection is positive 19.78, but in the compound 2, alpha protection is minus 41. The difference in ECD also was clear, was obvious. The positive peak was eliminated, and we had 2 negative peaks at 211 and 241. Other compounds were illustrated as well. Then we go to semi-synthesizing of one of the compounds that we get input quality. As you know, because of the lactone group in sesquiterpene lactose, these compounds are electrophilic. And attached to DNA and proteins in the cells. And they are very reactant, and we can think to this compound as ROS producing agent. Because of that, we decided to remove hydroxyl group and reduce antioxidant capacity of this compound by reacting them with pyridinium chlorochromate reagent. Pyridinium chlorochromate agent is a mild oxidizing agent that oxidizes secondary alcohols to ketones and primary alcohols to aldehydes. So, after that, after oxidizing this compound, we got a mixture of 2 compounds. After 20 minutes, the mixture gets dark, and we found that the synthesis is finished. We checked also with TLC. And using preparative TLC, we separated these 2 compounds. We also go to acetination. Eventual acetination is a simple method that, because of drawing the electron in acetyl groups, you can use this method to reduce antioxidant capacity. Because of that, we use anhydride, acetic anhydride in treating in 50 degrees centigrade under nitrogen for 1 overnight, and acetylated the compound. And taking a spectra, we confirm the product are made in compound 7. 2 ketone groups are here. HNBC also confirm the structure as well as high isolation SI mass. In the case of compound A, only 1 ketone group is here. ISNPC confirmed the place of synthesis and where ketone is located on the structure. High resolution mass has been confirmed. Acetyl group also will confirm through presence of a sharp singlet nickel group at each NMR at depth of 2.0, and also residues of acetyl group to acetate group and 170, and others, and also loss of 60 units from the mass in ASI mass spectra. We got other sesquiterpene lactones from another Artemisia forasignica. Even so, these two plants they've grown near to each other and the structure resemble each other, but there was a very interesting difference between them. This difference in the orientation of methyl 13, as you see, compound 1 was common between two plants, only compound 1 was similar in both plants, but in other compounds, if you see, methyl 13 is alpha oriented. We got two new compounds and one novel compound with very regular structure, and one non-compound and a common compound which is neurons. We elucidated the structure by regular NMR, CNMR, and 2D NMR, and also determine noisy configuration carefully using the noisy spectra. Compound, another compound, compound 11, elucidation by 2D spectra, noisy by stochasticity, relative stochasticity by noisy, and absolute configuration is, say, compound 11 resembles compound 1. In compound 1, we have a positive cotton effect at 224 and one negative cotton effect at 211. But here, the negative cotton effect is eliminated, and we have only positive cotton effect. It is experimental ECD and it is calculated, which these two resemble each other. So, we go to the novel compound, compound 12, which is from a monolite structure. Previous compounds were from Udes monolite. As you know, German monolite, Udes monolite, they are very common. Guanolite also, but monolite structure are very rare. Mostly, monolite compounds are reported because of the hook rearrangement and regarded as artifact because of the thermal condition, high thermal. But it could be also produced from germacranolite or monolite compounds because of highly oxidative condition in biosynthesis that could be because of fungi or fungi X. As clear here, we got 4 methyls in this structure. They are very uncommon in sesquiterpenes. Another uncommon things, but a hemiacetal methane at the delta C of 97.6. Hemiacetal methane, carbon number 2. However, we elucidated the structure by 2D spectra, and histochemistry, biology. Then we go to biological activity for both anti-cancer activity and anti-leishmania activity. We check compound 1 to compound 9 by MTT assay, again to prostate cancer cell line, LNCAP, which is androgen sensitive, and DU145, which is not sensitive. As you see, among all of these compounds, compound 6 and compound 8 show better activity with IC50 around 17 to 40. If we check the structure 1, 2, 3, 4, 5, and 6, pair this together, compound 6 with better cytotoxic activity lacks the hydroxy group at C8. So lack of hydroxy group at C8 enforced activity. If we check compound 7, 8, 9 with compound 4, presence of ketone group at C1 increased activity. But presence of ketone group or any other group in C8 reduced that. And if we compare compound 1 and compound 2, which are equivalent, compound 2 with alpha orientation of methyl is more than compound 1. So we concluded that alpha orientation at C4, lack of hydroxy or any other substituent group at C8, and presence of ketone group or reducing the oxidant capacity, especially at C1, increased activity. We check the apoptosis using flow cytometry analysis, and we found that this compound has network. This compound predominantly kill androgen sensitive cells by necrosis, but kill not sensitive cells by mostly by apoptosis. We go to mitochondrial mechanism and check one of the compounds in the quantity compound 4 on reducing mitochondrial membrane potential as one of the starter marker of apoptosis, and we found that dramatically, was dependently, this compound reduced the mitochondrial membrane potential. Then we go to ROS production and check our production of ROS and found that even at lower macromolar, it increased reactive oxygen species, which is the main mechanism of sesquiterpene lactose, and confirmed that cytotoxicity is through mitochondrial mechanism. After that, we check the activity of other compounds from Artemisia horasanica or anti-leishmanial activity, and we found very good activity in a massive and major leishmania major with IC50 value of 6.5 after 24 hours and 4.9 after 48 hours for one of the compounds, elemonolide, which showed the better activity, much more better than standard regulamin and timulate, with 15.5 at 48 hours. We checked the cytotoxicity on normal macrophage, murine macrophage, and found the selectivity indices of compound 12, 88, but the standard drug 40, compound 4 shows to better shows to be better both in activity and selectivity index. Because of this point, that this parasite in amastigote variant live in macrophage, mononuclear macrophage. It is important that they silence the apoptosis in macrophages and it lets this parasites to be survived. We think probably subsequent lactose because of ROS.
Sorry for interruption, please.
Yes, I understand. Only 30 seconds. Sorry. Because of ROS production, they put a start apoptosis process which is silenced by the parasite, and because of that, they show the anti-parasite activity. Thank you very much.
So, only one question is no question? Okay. On top of our next speaker is Session-03. He is from Division of Pharmacology, Pharmacogenology, Department of Pharmaceutical Biosciences of Sala University, Sweden. Hashim has interest in the area of isolation and structure, elucidation of biologically active natural products from medicinal plants, marine bee products, synthetic synthesis and biosynthesis of these compounds. He has won several awards and honors also to his credit. He has presented his research at several scientific conferences worldwide and received awards, and most recently the award in 2019, that is adjunct employment professor at Yonshu University, China, 2019. Appreciation certificate from Kyoto University, Japan about his lecture and joint collaboration, 2017. Prize for best presentation and paper from the Association of Arab Researchers in Bees. He is functioning as a joint professor at Jingshu University, China. He has published more than 300 articles in peer-reviewed international journals of international repute in scientific papers, reviews, chapters in peer-reviewed international journals among them. The Lancet Current Impact Factor 59 as well as scientific reports in Nature too. So he is presenting his online presentation, and so I welcome Hassan El-Sidi to talk on this title of presentation, the role of secondary metabolism in resolving biological questions, unexpected results. So please, I welcome him to proceed before this session. Actually, Mr. Hatem, we have no voice from your side. I think you have either closed your mic or something like that. So if you please can help us to listen to your voice, or your voice is not coming.
Can you hear me now? Is it better?
Yeah,
Is it better?
Yeah, it's okay. It's okay.
All right. So I just say that I hope from the outcome that you learn from my mistakes, that you must publish your results as soon as possible to avoid that somebody publish it. I will give examples about our failure and about our success. So this is a teamwork we are working. It started from ethnopharmacology, which means that we communicate with people's used plants or natural organism in traditional medicine and see about their uses. Then we start by chemistry in combination with pharmacology to see the bioactivity. And then we use the art techniques for isolation and structure elucidation in order to get the bioactive compound, hopefully for clinical and preclinical studies. I will take it as a challenge, and the first challenge about regulations of traditional healers. If we look to the Middle East, we are very rich in plants. However, we have some problems in the developing countries, and these problems, it is about poverty, and one another problem is schistosomiasis. Schistosomiasis is a serious problem, and about 500,000 deaths annually, every year. We had been writing paper about that and about the source of to get the parasite which affects the liver, and then it make liver complications. Look what happened before we publish our paper. Another scientist published the paper in Nature. So this is the first mistake you can learn. And they exactly mentioned about the same idea. Another problem is about desertification of land. You can see here, it is about rapid destruction and disappearance of natural habits, which pushing many medicinal species to be destroyed. We had been also writing about it, and I used some photo from Malaysia, as you can see, but look to the paper published again in Nature. So you see, this is a serious problem about publishing papers. You have to put a priority for that. From this point of view, we have a problem about drugs. The problem is the high costs and also the drug resistance. High costs is not a problem in Sweden and in Europe, but it is still drug resistance is a problem. That is why we should be back to nature. Look to the Nobel Prize in Medicine by Chinese and Japanese. It is about artemisinin from Artemisia herba alba. This encouraged scientists to be back to the nature. When we be back to the nature, it means that to deal with traditional healers and to see what is the scientific evidence. So from this global pharmacy course, we interacted with traditional healers to select plants used, for example, as anti-cancer, like in this case, and we look, if you look to the activity, this is the plant is recommended by traditional healers. It showed activity as the man has said. And for the other plants, it was no activity. We followed the activity by usual bioassay guided isolation in order to isolate the bioactive compound, and we publish this work in journal Ethnopharmacology using this way of methodology. And so it means that to be back to the nature and to interact with the people use the plants in traditional medicine is a key point for drug discovery. Another story about unexpected results. We take two species, which is 5,700 years ago. You never expect that this could give any compound. But surprisingly, we could found that it still contained mescaline. Of course, we approved practically the age of the plants by radiocarbon data that the age is correct. We found that it is still contain mescaline, which explains the displayed psychotropic properties. And we published this work successfully in Lancet. So this is our success after failure. We are very happy here, not because we eating mescaline. You know, the mescaline, if we take it, it is hallucination. It makes you happy and the world is green and small. But we are happy, of course, about our publication in Lancet. We continued this to see if there is any more unexpected results from the cactus, and we found that it is still also contains a bioactive alkaloid, as you can see, and we published this work in Journal of Psychoactive Drugs. This is more synthetic compounds which we compile and it showed activity. That's why we have a good contribution in this area, and this is one of the big book in pharmacognosy. They discussed about our interesting results in this area of research. As I usually say to the students, please think outside the box. So, since this cactus species give unexpected results, we try to see if it contains also polypeptide. However, polypeptide has never been isolated in this Cactaceae family. But this is how you can sometimes discover new things. So fortunately, we discovered for first time a polypeptide with 35 amino acids, and we did the structure elucidation, as you can see, and we tested the antimicrobial activity, and it showed positive activity as antimicrobial. And this is the three-dimensional structure of the polypeptide. We compare it, the sequence, with the structure of spider toxins, and it is closely related. That's why they choose our publication as cover page for the journal, and we got a certificate of excellence from the journal. We have been looking to the nature as a source of drugs for all the time, and we found that Egypt has the longest history of medicinal plants, followed by China, India, and Greek. And this has been published by the Greek scientists Neumann and Craig in Natural Product Report. From this point of view, we are very much interested about plants which has been used in very old time. So, and this is another approval about to look to the plants which has been also mentioned in Luxor and Aswan 1,000 years ago. From this, we look to the plants and we are doing isolation structure elucidation of these historical plants. And fortunately, we get these plants after acceptance from the Egyptian Museum in Stockholm. This is one of our theses which is going on about these plants which has been stored for a very long time, and the work is going on successfully. Then I will mention to you another very critical paper which has been taken from us more than 8 years. And this is about Islamic medicine. So we would like to publish a paper about plants mentioned in Holy Quran and the Hadith. And this, what is the aim of this work? The aim is that to take these plants, since it has been mentioned before, pharmacy and the medicine, and see about its chemical structures, preclinical and clinical studies which has been done, or what we should do. We also correlate this with Greek, Roman, Persian, Chinese, Indian, and we would like to publish this work based on scientific evidence. So we take these plants, like for example, siwak, which is as antimicrobial, as well as other examples, and see the traditional uses. Extract, what is the compound has been isolated, what has been done in clinical and preclinical studies. So we studied this based on scientific evidence, and we submitted the paper to journal Isnopharmacology. We have a problem. And the problem is that to remove Holy Quran and the Ahadith from the title. And I reject that because this is the main idea. And I told him that not because I am Muslim, we respect all other religions, but we explained based on scientific evidence. We had been struggling for almost 2 years with the journal, and look at the final. This is a letter from the editor. He says that I assume, while I understand your frustration. So he admitted that I was frustrated. But at the final, he said, I'm pleased to inform you that the paper has been accepted. And at the end, he said, thanks for this paper. It is a stimulating idea and may give rise to some interesting discussions. This was great work. I'm very happy about this publication, even more than the Lancet paper. Why? Because of the title. Plants mentioned in the Islamic scriptures, Holy Quran and Hadith, traditional uses and medical importance in contemporary times. Not because of anything, but I would like to show that our religion is not terrorism, is not killing, but it is a peace. It is about, it gives good ideas about scientific. If we look to it from these positive sides, this is very good. So it is not the problem of Islam, it is a problem of some people who misinterpret Islam. Then we continue the work and we take travel. I think it is open now for any Muslim country, with all respect to all other religions, which is mentioned clearly in Islam, that we must respect all other religions, that we discussed also about travel. And we say in the title, from Islamic culture to chemistry, pharmacology, and the food trends, and we could continue the work based on what has been done, what has been mentioned in Holy Quran and the Hadith regarding treating eyes, for example, in this truffle species, and what we can see also as importance of this truffle in food, and we could publish this work in Trends in Food Science and Technology. It is about truffles from Islamic culture to chemistry, pharmacology, and the food trends in recent times. I think the area is open now. If you would like to publish about Holy Quran and the Hadith paper based on scientific evidence, you will not find a problem anymore. Another thing which we are interacting with the society, we must be back to the nature, not only from drugs, but also as a food. So why we go to junk food? We have to also focus on eating vegetables and fruits. Look what it contains. It contains very simple compound, but it's still very active compounds, like these examples. And we showed that it has antimicrobial, anti-Alzheimer, antioxidant, anti-cardiovascular. And this we published in Journal Agriculture and Food Chemistry. It is one of the most cited paper because of we discuss also the dietary intake from this. And we go to another thing which is about bee products. We made a good contribution, I think, so far in this area. It is mentioned as a whole surah in Holy Quran about bee. And I wish to ask you, who is eating bee in daily life? And why it is important? And is it only honey? Or you are care also about bee venom, bee wax, bee bread, propolis, royal jelly? And what is the scientific evidence and benefits of that? If you look to the literature, it has been mentioned about several, but look to what we have done, for example, in bee bread. We have identified such a great mix of compounds of different classes, as you know, fatty acids, flavonoid glycosides, etc. And this type of compounds, we had been proven that it showed various biological activities. Another nice story, which we made it in the lab, it is about beehive. What is the effect of beehive? Is this could treat asthma, which is a serious problem, without using any chemicals or any antibiotics? And what is the scientific evidence of that? From uses in traditional medicine, it should treat asthma. But what is the active compound and what is the activity? So this was lack in this point. So we go for this area for the first time, and this is a very simple way of the protocol that we take the various types of B products and we submitted it to GCMS analysis, which we all have access on it. And fortunately, we could identify 56 volatile compounds of different classes of natural products, as you can see. So we solved the first question, which about chemical constituents. And this is the most abundant volatile compound of different classes. Then the second question, what will be the activity? It is really active or not? This is the scientific evidence. And we found it has antimicrobial activity, as you can see. We make it also the activity of the different constituents of beehive, bee venom, with comparing of drug control, and we showed that it showed activity, and this is the most active compound we found as anti-asthma. So I think this was solved the problem. Another good example, it is about bee venom. Maybe you will be afraid if the bee bites you, but this is very important for you, especially if you are not allergic of it. Why? Because it has a maligin with very high amount, and this is a very good compound as anti-cancer. So this we have been studied during last year. So this is unpublished data, which we are going to publish it soon. We are working on this area in clinical studies now. It's about bee products, how it can make a very good wound healing, even for diabetes people. And the work is going on as well in cosmetic applications. We take in this as well the bee pollen, another bee products, and we found such a great mix, which is naturally, and this was we approved by metabolomic studies using HPLC, MS application, and this is what we found, that it improves the dysfunctions as well as prevent heart damage, it controls diabetes, etc. So this is what we published in Nutrientist just a few weeks ago. The final is about royal jelly. And royal jelly, it has this bioactive compound royalcine. And this royalcine have 51 amino acids. The compound has been isolated about 30 years ago, but nobody has been synthesized the compound because of the problem of the disulfide linkage. As you can see, it has 3 disulfide linkage. This was a challenge which we have been taking during the last years. So after 2 years of trial, just about 1 month ago, we could successfully synthesize the royalcine, which is the main active compound of anti-aging of the royal jelly. The last we are working in bee products is about honeybee as a potential neuroprotective agent, and this is the bioactive compound which we have been so far working on it. Then we correlate the propolis as a final bee product with COVID-19. So we found that the propolis contains a bioactive compounds, and this is one of them, as you can see when we study it through molecular docking. So I think this is good to correlate also our work with molecular docking and the chemical space in order to make shortcut to see what is a bioactive compound. So this is what we found here as a bioactive SARS-CoV-2 COVID-19 studies. We are working and very much interested about honeybee products in preclinical and clinical studies as well. This is going quite well right now. And this is some of our publication in this area. In the final also, regarding this food chemistry, we recently studies about biological and conventional food processing modification structure, what is about the functionality and the bioactivity. So we found that the food proteins are essential nutrients required to maintain various body functions and human health. From these different sources, we have been identified how much this is important to maintain the body functions, and this is one of the publications of last years. I will end with this. how we can interact also with COVID-19 as a natural product. And fortunately, finally, that they admitted that we should be back to the nature even in this area. And this is what we had been trying to find, is to highlight the role of natural products, especially medicinal plants, microorganisms, marine, and their derivatives as a promising drug lead against various types of COVID-19. So we take some examples with different classes, and we see what is the activity as antiviral and anti-COVID-19. What about the immune system? And this is what is the conclusion from this work, that COVID-19 is hazard for the people who have weaker immune system than healthy one. So strong immune system is essential for fighting against COVID-19. Consumption of healthy diet is one way to boost the immune system. There is wide range of plants that contribute to boosting the immune system, giving the high content of variety of nutrients and the biological activity of the compounds. It means that we should be back to the nature in order to increase our immune system. And this is what we showed with examples. And what is the activity of this, for example, in vitamin A, in citrus as well. So this is a screening of natural derivatives of bioactive compound in preclinical. This is one of the paper we just published, and it has a high citation. We looked also for the spices and how spices could play a major role as anti-COVID-19 in connection with molecular decking as well. And we found out that this is 32 compounds we found identified as inhibitors of SARS-CoV-2. And then we discussed them based on molecular docking as well. And we found the most active one is sulfonolic acid from this study. I will end with that one, that this is one of good memories with your institute. And this is how I am doing my best to contribute to ICCBS. Not only from the point of joint publication, but all the time I'm very willing for thesis evaluation and the papers. This is how we should collaborate with each other, even when I'm very busy, but I still care to do my job regarding this. This is our duties, as well as visiting Pakistan for several times to give lectures. So cooperation is very good. We will be more strong together, I think. With this, I will end with the acknowledgement. Of course, I am very much indebted to SIDA for financial support of Uppsala University, KTH, and also Japan as well. You are most welcome to visit us in Sweden. Hope in summer, not in winter, because a lot of snow. And with my original home country, Egypt, who I am contributing still, and all the international prizes I donated to Egypt because I had been originally from there and I got my education in the beginning there. Thank you very much for your kind attention.
Thank you, Professor, for your very nice presentation. A very short question, if someone can have. No question. So we will proceed for the next session, and by this I will hand over the chair to Professor Dr. Raza Shah for the next session. So I welcome him. Please. This is an announcement. The next session will start immediately. I now request Professor Dr. Raza Shah to chair the next session. There are also an announcement by the organizing committee.
For all registered participants, cultural evening is arranged in the auditorium at 7 p.m. today, followed by gala dinner. तमाम तालिबे इल्मों से गुजारिश की जाती है कि अपने कॉन्फ्रेंस कार्ड या रजिस्ट्रेशन रसीद अपने साथ लेकर आएं। ये गाला डिनर में दाखिले के लिए जरूरी है। There is another announcement that all the registered foreign participants kindly gather in front of the auditorium at 5:45 p.m. as the visit to the institute will start at 6 p.m. sharp. Thank you.
It's given me a great pleasure to initiate this session of the afternoon. And the first speaker of this session is Vinita Tandani. She is an associate professor at Sri Lanka at Islamic Academy. She has received numerous awards, including Presidential Award for Scientific Publication, several awards from Institute of Chemistry, National Chamber of Commerce, and Corporate Society and Responsibility Award by Japan. The U.S. state government has recognized her as a leading women scientist who has made significant contribution in the field of STEM in Sri Lanka. She is a founding member of Global Young Academy and founding president of Sri Lankan Academy of Young Scientists. She will be talking about sustainable natural fabric dye utilizing waste generated through instant tea manufacturing process. So we are looking forward to Dr. Tandani.
Good evening, everyone. Assalamu alaikum, and I go on from Sri Lanka. I'm sure you all had a full of lectures, but I just want your 15 minutes attention on this a different type of aspect of natural products which I have been doing. So a sustainable natural fabric dye utilizing waste generated through instant tea manufacturing process. So this is what I'll be explaining in my next 15 minutes. So the basic income of Sri Lanka is generally from two things. One, we export fabric, right? The apparel and the textile industry and the tea industry. These are our two major sources of income in Sri Lanka, right? So textile, of course, is the highest, like 43%. Tea, even if we have been selling tea for like past 150 years, it's only like US dollars 1.9 billion, but the not so, I mean, the Sri Lankan export of value addition is less than 1%. So that is the most concerned aspect for Sri Lanka, because we are just selling raw materials, not any value addition. So in my project, what I have been looking for is to do some value addition of natural products, right? So if we look, there is a strong R&D investment globally for plant-based dye. Why? Because the global textile dye market is like US dollar 10.3 billion. It will reach like 10.3 billion by 2026. The fashion industry is increasing. So day by day, the fabric dyes are being manufactured. So what will be the environmental impact in such a huge synthesis of synthetic dyes, synthetic organic molecules, right? Of course, as I told you in my first slide, Sri Lanka's income comes from textile dye. So therefore, we are increasingly increasing our import of textile dyes, and we pay like 18 million to export these per annum, these synthetic dyes. So huge amount of cost can be minimized if we introduce a natural textile dye to the industry. But saying so, what are the challenges we have to overcome if we want to introduce a natural dye? One, availability and sustainability. For example, let's say prominent peel. It's a good source of natural dye, but who will collect all the prominent peels from every houses and manufacture a textile dye? Who will do that, right? So if we are thinking of a natural dye, you have to think about the availability and the sustainability, right? Second, reproducibility. So prominent peel from Karachi or prominent peel from Islamabad or from Sri Lanka in different seasons will have different varieties. So how do we keep the reproducibility of the natural dye? So that's another challenge. And of course, it's a known fact that synthetic dyes and in other around synthetic dyes are produced in the laboratories. So you can produce them, reproduce them in the same manner, right? So, and other thing, the cost. Normally, natural textile dyes have to be used in a large amount than synthetic dyes. So then how do we balance the cost? So these are the three major challenges which we have to look if we are thinking about the natural dye. So on the same said so, on the other hand, Sri Lanka is the largest supplier of instant tea. What is instant tea? Instant tea is something like Nescafe, what you just put into your coffee and it just dissolves. So instant tea is something like instant coffee, right? So Sri Lanka is the largest producer of instant tea, supplying 70% to the global market. So all the Nestle bottles, what you drink, like ready to drink green tea, iced tea bottles, which is made from instant tea, right? So Sri Lanka is a major supplier for those PepsiCo companies. So during the instant tea manufacturing process, there is about 20 metric tons per day waste generated. Per day I'm talking about, right? So what we were looking at is, can we use this waste as a textile dye? So basically I'll just explain. So if we take a tea plant, the topmost leaf is the highest quality leaf, which goes as say grade 1, the second one grade 2, grade 3, and these are kitchen grades, right? So we export these top quality tea leaves, which is around 300 metric tons per annum, right? And local consumption is about 20,000 metric tons per annum. So when we export these full leaves, there are bits and pieces broken which are not exported, so they are left down, right? So those are called broken mixed fannings. So part of these, part of these, part of these, right? So those are called broken mixed fannings. So broken mixed fannings and extract the tea out of that, and it is called instant tea, which goes for the 70% of world supply, right? So the waste generated during the instant tea manufacturing process was developed as a textile dye. That is what I'm going to explain to you now. So I explained to you the challenges of natural dyes. We need continuous supply chain. So we have overcome that. We don't need, because the instant tea manufacturing process has been taking place for past 60 to 70 years, right? And they always think about the quality of their product. So if they are maintaining the quality of the instant tea product, naturally the quality of the waste is also maintained, right? And so uniformity, continuous supply chain, and further this can be converted into a soluble powder form like synthetic dyes. And another advantage is as we are using something as a waste, we are cutting down on the carbon dioxide footprinting. Sorry about it. So we take the broken mixed panics, that is the bits and pieces left over after the good quality is exported. We do a hot water extraction. So like 70% is thrown off as a spent tea leaves like lignin, cellulose complex, hemicellulose products, those goes as the spent tea leaves. 30% is the extract, which mainly consists of polyphenols, little bit of caffeine, small protein, small amount of sugars, but mainly polyphenols. So this is our source of the natural dye, right? So we did the chemical control analysis using LCMS-15 and found over 100 compounds present in these tea extracts, precisely about 121. So the tea extract goes several processes, and part of the several hydrolysis processes of the tea extract undergoes several enzymatic hydrolysis processes, and the filtrate goes as instant tea, and the residue or the sediment fraction after the instant tea is produced, it is formed as the tea dye. So we have done qualitative analysis of this tea dye using MCMS-15 and found several compounds, and our tea dye showed comparatively higher percentage of isoflavone glycosides and was lower in flavonol glycosides. So the two instant tea and the tea dye were completely different products, as seen from this heat map. The green portions in a heat map shows lower concentration of certain products. The red shows higher concentration of these compounds, right? So if you look at the instant tea, which goes to the tea drink bottles, have different compounds, whereas the tea dye which we produce were higher in hydrophobic molecules, which bind better to the textile fabric. So basically, still we have to overcome another factor, because tea, even though the tea dye, we have to still increase its effectiveness to bind to the fabric. So basically, all our compounds are polyphenols. They are negatively charged. If you look at the cellulose molecule also has OH on the surface. Still, they are negatively charged too. So how do we bring this polyphenol and cellulose together? So we have to include a ligand, a polyamine ligand, which will bind from both ends, one end to the surface of the fabric and from the other end to the dye. Right? So this was done using polyamines such as chitosan. So during the heating process, we had turned the OH molecules into phenols. That was switching tea dye, right? And using polyamines, we had formed a Michael type adduct, which was actually the binding portion which bound to the fabric. So during this process, we have reduced the carbon dioxide, even to synthesize. So the acid dyes, viscous dyes, reactive dyes are the three types of dyes used in textile dye. So to produce a organic compound, we are using energy, right? So to dye 1 kg of fabric using acid dyes, we are using 726 kilograms of carbon dioxide equivalent, right? Using dispersed dye, 737, the highest goes for reactive dye. But as we are using something as a waste, we are actually getting a minus CO2 emission, right? And even the dyeing cycles, dyeing time, water consumption, and energy consumption, waste disposal cost, all were cut down on this method. And this was a win-win collaboration, a collaboration between Unilever Sri Lanka, which is producing the largest instant tea. So they had a huge problem of how do they dispose their waste. Then there was a fabric dye industry which was looking for eco-friendly, sustainable, natural dyes to market their products. And the Sri Lankan Institute of Nanotechnology, which was the research and development partner to bring these two parties together. So it's a tri-party collaboration, and we had obtained a patent. And furthermore, when using this dye, we dyed the fabric using the available standard protocols. It passed all the requirements, and it has been commercialized as tea use for various reputed brands like Pink, Mark & Spencer, Levi's, and Star, and it has brought an export earning of about $2 million for 2021 from this product. And I would like to thank you for your attention. Thank you so much.
Okay, session is open for questions. So we have time for 1 or 2 short questions. There is any question you may ask. Look like it, there is no question. So let me thank Dr. Tandani for such a wonderful presentation, and thank you so much. And Dr. Tandani, you have a smart gift from the organizer. So it's my pleasure to introduce the next speaker of this session, who is Samia Taslim. Samia Taslim is CEO founder of research in UK and University of Karachi and innovation leader. She has been associated with University of Karachi, Open University, and many other organizations. She has received many awards like Pakistan Dance Health Innovation Award, first prize in 2016, International Agency of Standard and Rating recognized Dr. Samia Taslim among world's 500 most influential microbiologists for the year 2017. She is also editorial member of several international journals. She will be talking about production of xanthine gum from Xanthonus campestris isolated from cruciferous vegetables. So, Dr. Samia Taslim.
Thank you for ICCBS give me opportunity to talk very important topic. This is the also used for technique for waste management is the larger issue for all over the world. I'm microbiologist. So my topic of this paper is production of xanthan gum from Xanthomonas campestris isolation of cruciferid families. This is my short introduction. I'm working leading organization. Last year, we developed the Center of Innovation and Health Transformation. Those young scholars join us to develop innovation team and innovation Pakistan. The introduction of our presentation, blackroot is very common in Cruciferous family. They cause plant pathogen Xanthomonas species. It is also commercial production for xanthan gum. Xanthan gum is a high molecular weight polysaccharide which is many important use especially in food industry. These are Cruci family, mostly used in daily routine in all over the world. These are the life cycle of Xanthomonas as a use as a pathogen, but we are used as a industrial production of xanthan gum. These are the common plant infected. These lesions are produced. Mostly plant scientists, it is caused by the rot of the whole crop and destroyed by the burning and create a lot of pollution of environmental factor. But we are reverse engineering. We isolate these products for xanthan gum. These are whole life cycle, how to plant infect by the Xanthomonas. The symptom of this disease if you are present in the crop. We isolate these crops from this one to these infected vegetables to the production of Xanthomonas. What are the Xanthomonas produced by xanthan gum is a polysaccharide as a secondary metabolite to defense our to production to infect the Cruciferous family and do the extra virulence factor and produce the epidemiology of the plant. But this xanthan gum are polysaccharide used in many years for the production as a thickener agent, stabilizer, and for process of the use of different industries. Mainly xanthan product is used in food grade, industrial grade, food grade, and medical grade. These xanthan gums used for adverse drug delivery, brain drug delivery, ophthalmology, topical drug delivery, tissue engineering, liquid dose of form of many medicine, cosmetic, and solid dose of different medicine. It is used many different industries as a basic ingredient. It is also used for the stabilized blood glucose level, reduce cholesterol level, weight management, cancer prevention, stop the bowel syndromes, and thickener agent of many food products. Xanthan gum also used for pigmentation, fertilizer, wheat, toothpaste, high quality paper, and textile pigmentation. These are the mixture of polysaccharide used in many ways. It is also used in waste management, wound healing, and latest technology are tissue engineering. Demand of xanthan products is day by day increase. The function of mostly geographically North America, South America, Europe, and some other countries use xanthan gum for application, food and beverages, oil and gases, personal care, medical, and other use. In global market 20 to 30, the xanthan gum production increased demand for the 4.8%. How can produce xanthan gum from these species? Xanthomonas is a microorganism. It is a technology or fermentation technology. The production media is add and xanthan isolate by precipitation and xanthan purified by the different reagents. These are the philosophy. What are the chemical reactions behind? Because simple glucose and oxygen and ammonia combine in the cruciferous family produced by xanthan gum cells, carbon dioxide and water. Water is evaporate, carbon dioxide also evaporate, cells are remaining and xanthan gum are produced. What are our statements? We collect the samples for field and sampling, we collect the yellow lesion and black lesion field. The sample wash and disinfect by ethanols and sterile condition are adopted. These are the leaves. And after the sterile condition, we crush the leaves and isolate the organism and increase the culture growth. We use peptone sucrose as a medium. After the growth of 48, we isolate these isolation colony and identify by different microbial techniques, and it is culture stored by the refrigeration. This is the culture characteristic of Xanthomonas species. After the xanthan gum isolation of Xanthomonas species, we adopt the certain techniques for the production fermentation techniques to isolate the xanthan gum. In our different species, we use different subspecies type to be called the different numbers. X1, X2, X3, X4, X5, 6, 7, 8. So we isolate xanthan gum major X4 0.57 gram per 100 ml. Is a large yield isolate for our experiment. We check the viscosity of these samples. So most viscous samples are X4.27. If this procedure goes to the industry in future, the fermentation, sterilization, precipitation, separation, drying and milling and packaging, we are isolate the xanthan gum for the waste material. These are whole industrial paragraph we adopt, inshallah. These are the functional application now applied. In future, we use these xanthan gum for nanotechnology development or some nano patches and other medical care equipment. The medical xanthan gum is also used to control the diabetic. The diabetic is largest metabolic disorders, very common all over the world. It is also used as a laxative agent. The global market is bright for the production of xanthan gum. It is also used in tissue engineering control for different arthritis and different eye problems and different other medical emergencies. Thank you for attention. This is a very short research paper for me. Any question?
Okay, so there is one question. Can you just ask online?
Thank you for your presentation. I would like to ask whether you have different Xanthomonas campestris strains in order to produce the xanthan gum, and whether this xanthan gum produced by different, if you have, whether this xanthan gum produced by different strains has different properties.
We isolate Xanthomonas species for different region of the Pakistan. So sometimes the soil condition affect to the production of xanthan production. because the lot of environmental condition affect to the disease surveillance of the crucifery family. If the crucifery family are the infect and penetration of disease is very less, so organism production and nutrient supply of these strain is very poor. So that's why the properties and genetic modification occur in the Xanthum monas species. That's why the production of xanthum gum is different. So we are our next plan to the screen out the larger production of xanthum gum species for these best material and sequencing of these species and then cultivate to the larger production of industrial use.
Okay, so is there any further question?
My question is the crucifery family parts the only source of xanthum?
No, it is mostly used for many vegetables, but we are the use for only this vegetable because it is easily available in our market, and we use easy to access to collect these these organisms for these vegetables. A lot of vegetables are infected for these black fungus and xanthomonas infection.
This is the only richest source of xanthum gum. Is it the richest source of xanthum gum?
Due to the chemical effects of xanthum monas, due to the impact of xanthum crucifery family, is produced large amount of xanthum gum. It is reported in different journal papers.
Okay, so there is no further questions. So thank you very much, Dr. Sami, for sleep. So please don't go away. There is a small gift from the organizer. Next speaker of this session is Dr. Uzma Salah. She is a research officer at the Dr. Punjabi Center for Molecular Medicine and Drug Research. Dr. Uzma Salah earned her PhD degree from our institute at ICCBs Research Institute of Chemistry. She did a postdoc from University of Bordeaux, France, in the field of membrane biophysics. She has published more than 80 research articles with impact factor of 233, citation 1200, and index 22. She would be talking about metabolite repair in ADPH hybrid dehydratase enzyme from vancomycin resistant Staphylococcus aureus, cloning expression functional assay by NMR spectroscopy, and in vitro ROS inhibition. So Dr. Uzma, over to you. Thank you so much.
Thank you so much, sir, for this nice introduction. I'm presenting here my most recent work related to the field structural biology by using NMR spectroscopy. So the title of my presentation is Metabolite Repair NADPH Hydrate Dehydratase Enzyme from Vancomycin Resistant S. aureus. The work comprised of cloning, expression, functional characterization, and ligand screening by NMR spectroscopy and in vitro ROS inhibition. As I think everyone knows that NADH and NADPH are the vital cellular redox cofactors and labile coenzymes. So due to being labile in nature, they undergo decomposition in cells. And here I am talking about the bacterial cell. So in bacterial cell, these NADH or NADPH undergo the hydration reaction. Due to certain undesirable enzymatic side reactions, chemical modifications, and other unfavorable conditions such as heat. So the most favorable site for the hydration is this 5-6 double bond. this nicotinamide ring. So the hydration occur at these 5-6 double bond and 2 epimers will form R and S. So these hydrates are non-functional in nature. In case of NADH, they are non-functional, but in case of NADPH, the NADPH hydrates are found to be the strong inhibitor of very important enzymes. So the formation of these hydrates is not good for the bacterial health and may disturb the normal metabolism of bacteria. So the enzyme of interest, which is the NADPH hydrate dehydratase, what actually it does, it converts the S form of this NADHX back into its functional form. So this enzyme is very important for the bacteria and for the other cells because this enzyme is highly conserved in prokaryotes, eukaryotes, and archaea. So this enzyme is specifically catalyze the dehydration of S form of NADHX. So what happens with the R? There is another enzyme epimerase which epimerizes R into S. So as I told you, this enzyme is highly conserved, so it tells its importance to study its functional nature and its molecular identification in every organism. And this enzyme catalyzes this reaction in the presence of ATP or ADP. But can we form these hydrates in the laboratory? Yes. In mild acidic conditions or in neutral conditions, we can obtain the R and S hydrates along with the cyclic isomer. What happens when we incubate the NADH or NADPH in mild acidic conditions? We obtain R and S, and these two epimers are reversibly interconvertible. And at the same time, they irreversibly cyclize to form cyclized NADHX. So I use this strategy to form these hydrates in the laboratory. So this is my enzyme, NADH hydrate dehydratase, which actually dehydrates this enzyme, this S form of NADHX back into its functional form by utilizing molecule of ATP. What ATP will do with this substrate? Actually, ATP is a phosphoryl donor. It donates the phosphoryl group to this hydroxy and form the phosphate group, which eliminate as a good living group by phosphorylation and elimination reaction. And in bacterial cells, this unwanted metabolites convert into its functional form. Along with the repair, we can also call this enzyme as a metabolite proof reading enzyme because it repairs the unwanted metabolites in bacterial cells. Along with the repair process, this enzyme also play a vital role in stress adaptation and is known to upregulate under several stress conditions such as starvation, heat stress, and oxidative stress. I have told you that this enzyme is highly conserved in mammals, yeast, plants, and E. coli, and this enzyme is already been molecularly identified from these species, but this has never been molecularly identified from the genus Staphylococcus. So my interest was to molecularly identify this enzyme from the genus Staphylococcus along with its functional characterization by NMR spectroscope. So the study basically comprised of the molecular cloning followed by protein expression and purification, and then functional characterization by NMR spectroscopy, in vitro ROS inhibition. This is the gene sequence of this enzyme. This is the amino acid sequence of this enzyme. This enzyme comprises of 270 amino acids, 813 base pairs. So for the molecular cloning, I performed the gene cloning, the genetic engineering tactics to form the recombinant plasmid. So first the genomic DNA was isolated from the bacterial strain. I used the VR assay to obtain the template DNA, and then use that template DNA for the PCR reaction. So by using the PCR cycle, I just amplified the desired gene. I used this PSPDT expression vector to incorporate that gene at the particular restriction sites. So next, I performed the restriction digestion reaction by using the set of these two restriction endonucleases. Simultaneously, the plasmid was also digested and then ligated in the presence of DNA ligase. So after the formation of recombinant plasmid, that plasmid was transformed into the cloning strain and then bacterial strain by following the calcium chloride leach shock transformation protocol. And then protein was expressed by the induction of this chemical IPTG, which actually expressed that protein. So the purpose of using this expression tactics is to obtain the enzyme in sufficient quantity, because I want to perform the NMR spectroscopic experiments. So I need milligrams of that protein. So the protein was purified by using affinity chromatography. You can see along with the purification, it is very necessary to optimize the stability, the storage conditions, stable storage conditions. So I perform differential scaling calorimetry or thermal shift assay to optimize the buffer system. So I use 15 different buffers of different ionic strength and different pH. There is a thermal shift curve. This thermal shift assay was performed on real-time PCR. This thermal, you can see a very good, very nice looking sigmoidal curve. The low here on y-axis, this is the fluorescence value, and x-axis, this is the temperature then. So the starting temperature was 20, and after the increment of 0.3 degrees, the temperature was gone to 95 degrees centigrade. So this sigmoidal curve tells us very important information. The low fluorescence value gives the information that the protein is well folded. While as the temperature increases, the protein will be unfolded. And when it gets unfolded, the hydrophobic core of the protein exposed to the cipro-orange dye, which used in this assay, and form the complex. That's why the fluorescence immediately increases. And after making the complex aggregation occur, and the fluorescence, there is a quenching of the fluorescence signal observed. From this thermal shift assay, the best buffer would be this one, and that is the NES buffer, 20 millimolar NES with 150 millimolar NaCl of pH 5.5. So this is the software-driven melt curve, which tells the melting temperature of that protein. So the melting temperature (Tm) was found to be between 75 to 80 degrees centigrade in case of NES buffer. So after optimizing the storage condition or stabilizing buffer condition for that protein, the protein was subjected for the functional characterization by NMR spectroscopy. So the substrate for the enzyme, which is S-NADHX, is not available commercially. So I prepared it in the laboratory. As I got the mixture of R, S, and cyclic NADHX, so I used the mixture directly to perform the functional characterization. So before performing the enzyme localized reaction, I first characterized the NADH by recording the proton and NMR of NADH and fully characterize all the resonances according to the data submitted in BMRB. And then my focus was on the nicotinamide ring. So
what I did, I performed the 1D toxicity experiment to selectively see the resonances of this spin system. So here you can see all the 4 signals of protons present at the nicotinamide ring. So the reaction mixture, again, the proton NMR was performed on the reaction, the mixture. Here we can see that we obtain different new signals related to these isomers, but it is very difficult to characterize these signals directly on this proton NMR. So what I did, I performed several 1D toxicity experiments. By selectively irradiating these resonances, so I identify different 3 isomers separately. So I have performed several experiments, but here this is showing the signals related to the nicotinamide ring. So then after the characterization of the nicotinamide ring of all 3 isomers, the enzyme catalyzation was studied. But before that, I just first run the proton NMR of the reaction mix after adding the ATP plus magnesium chloride, which is the cofactor for that enzyme, in order to identify the signals for ATP and not to confuse with the new signals. Then after recording the proton NMR, the enzyme was and incubated the reaction mixture for 1 hour at 30 degrees centigrade, and again proton NMR was recorded. So there is very clear reduction of the peaks related to the S isomer was observed. You cannot see it clearly here, but here I can show you the zoom version of this part of the spectrum. Here you can see that the blue peaks are related to the S isomer, and you can see a clear reduction in the peaks of which are particularly related to the S NADHX. So by this method, the functional characterization was done. Along with this, I told you earlier that the enzyme is also involved to control the stress, oxidative stress in bacterial cells. So my colleague Dr. Almas performed the ROS inhibition for this protein, and she used 6 different concentrations, and this is a very remarkable result that the enzyme was found to be 13,000 more action in scavenging the ROS as compared to the ibuprofen. So this is the additional work which I just added yesterday. This was not included in my title, but because it is almost done, so I just added additionally. So I also performed the ligand binding screening by STD-NMR on this enzyme, because this enzyme have a very crucial importance for the bacterial cell, for the survival of cells. So 80 different commercial drugs and commercial natural products were used in this study. So I just broke all these compounds into 17 mixtures and directly performed the STD-NMR on these mixtures. What we do in STD-NMR, we have the enzyme and we have the mixture of ligands. We saturate certain resonances of the enzyme. Normally, these are the metal protons, which appear in the upfield region. So when we saturate these resonances, the saturation will spread over the protein, and then this saturation will transfer to the bind ligand by spin diffusion. So we can observe this binding by seeing the resonances on STD difference spectrum. The protons which will get the saturation will appear in STD difference spectrum. So we have identified the 7 different ligands which have the ability to bind or interact with the protein. So the selection was these are not the random selection of the compounds. So we choose the compounds on the basis of some structural similarity with the substrate. So all ligands have the nitrogen heterocycles. So on the basis of this, we select the AD compounds, and out of the AD compounds, 7 ligands were identified. These are the 3 representative STD NMR spectrum. Here in the STD difference spectrum, you can see the resonances, which show the interaction with the proteins. Amplification factor was also calculated for all the resonances. The most highly peak having the highest integral was set to 100%, and the rest of the peaks were set according to the related were calculated on the basis of their relative integral as compared to the highest integral value. So in the last, we have also performed the thermal shift assay again on the enzyme by adding these 7 ligands. And what we found that all these ligands actually decrease the PM of this enzyme. So which actually showing that these ligands are actually destabilizing the enzyme. So all these ligands have the destabilization effect. So we can use these ligands as a starting point for further study, the inhibition studies on this target. So this work is near to publish soon, inshallah. So in this study, metabolite repair enzyme was cloned and expressed and functionally characterized by NMR spectroscopy, and its Ross scaling potential was evaluated by oxidative burst assay. A range of ligands were screened against this enzyme by STD NMR experiment, and 7 ligands were identified. Those were able to destabilize this target. So these ligands could be the starting points to further study the inhibition of NADPH hydrate dehydratase by NMR spectroscopy and other related techniques. So I acknowledge Sir Professor Dr. Auditorium and Professor Dr. Iqbal Chaudhary for providing us world-class research facility, and Professor Dr. Aditya Wahab for her guidance throughout the research project. Last but not the least, my sir, Professor Dr. Khalid Khan, for all his support throughout my career. I also acknowledge the research project funded by ICBS under the Faculty Development Program. And thank you.
Okay. Thank you, Dr. Rosma, for such a nice presentation. So House is open for questions and discussion. Yeah.
Hello, thank you so much. That was wonderful talk. Well done. Some of this question, have you tried to crystallize the protein?
This in future I want to, because I observed that maybe I am wrong. My protein is with the passage of time start precipitation, but after 15 or 20 days, when I stored it in refrigerator, because this protein is stable up to 70 degrees centigrade by the thermal shift curve, and it is pressurized to confirm its stability. So when I put protein on the fridge after 2 days or a week, it starts precipitation. So might be it works for crystallization.
That's a word. We can talk later.
Okay.
Thank you very much. That was a very good speech. I have a question. Just wanted to know, for example, you did the protein ligand binding assay using STDMR. So I was just wondering whether you consider some thermodynamic evaluation of the binding affinity or not, or are you planning to do it in the future, like enthalpy, the stability of the complex that we have just showed?
Sorry, can you repeat?
The thermodynamic, for example, the enthalpy and entropy, the Gibbs energy. So I don't think I saw here in your presentation. So do you have plans?
Can you perform it by thermoship aspect? The entropy thermodynamic study?
No,
Because I
I
don't know how.
I think it is performed using ITC or DSC to show the stability in terms of enthalpy and entropy.
Okay.
Yeah.
Okay, we can discuss it later if you have some idea that can fit into this work. So why
Okay.
not?
Thank
Yeah, so I guess there is no other question from Dr. Rosma. So thank you very much,
Thank you, sir.
Dr. Rosma, for such a good lecture. And there is a gift from that also for you. So
Separately.
Mobile sweet translate इसमें बेचारे में क्या हो क्या आ जाए सब खाना Thank you.
okay, so with this, this was the last session of today's program. So we had a wonderful group of speakers who talked on various topics ranging from waste management to enzyme purifications and also zinc production. So we thank all the speakers by sharing their wisdom with us during this session. Thank you so much for the nice presentation. And there is also an announcement from the organizer that the tea and poster session will be at the lands of ICBs Research Institute of Chemistry. There are further announcements from the organizer. So back to you. Thank you so much.
I have a couple of announcements for today. For registered participants, cultural evening is arranged in the auditorium at 7 p.m. today, followed by gala dinner. तमाम तालिबे इल्मों से गुजारिश की जाती है कि अपना कॉन्फ्रेंस कार्ड या रजिस्ट्रेशन रसीद अपने साथ लेकर आएं। ये गाला डिनर में दाखिले के लिए जरूरी है। There is another announcement. All the registered foreign participants are requested to kindly gather in front of the auditorium at 5:45 p.m. as the visit of the institute will start at 6 p.m. Thank you.